So this presentation is basically a ripoff of one of my favorite presentations, which is called Real Software Engineering by Glen Vanderburg. It was given, among other places, in 2010 at Lone Star Ruby Conference. It's way better than mine, more complete, with full references to the original papers, and basically explains the origins of Waterfall and reframes software engineering and defines it in a correct way, more attuned to actual engineering. And what I will do, I will more or less recap the presentation, although I encourage everyone to watch it. Maybe not 20 times like I did over the years, but at least one. And then, since it's also a bit dated, I'll try to see if some of the issues and errors that were a problem back in the day are still here, and we'll explore like our situation and try to correct whatever we can improve in our daily processes and project environments. The presentation is this one. I will send a link below, and actually I tried to generate all the images, but I ended up grabbing them from 160's collections. They look much nicer than the AI generated ones. So let's go. So how Waterfall as a software engineering process came along. Nowadays, it's basically common culture that Waterfall is bad, doesn't work, or maybe it only works for highly repeatable projects. But even in that case, probably you should automate the highly repeatable project, so you wouldn't end up using Waterfall anyway. But the history of this approach is very interesting. So in the 60s, software engineering was basically started as an area of work. The first software was developed and used, and at some point there was a sort of software crisis. There were big projects failing, and like both on the cost and or reliability, or not completing altogether. So this NATO conference was started, in which the term software engineering was introduced for the first time in '68. And the conference, we still have the papers, of course, advocated for more or less reasonable practices, which we would fully agree today. Interlaced testing, iterative design, and a very sensible approach. Then there was another conference in '69, I think. That conference, if I recall correctly, was more academic, was less connected to the real practice, everyday practice of software development, and more or less paved the way for what would come later, which is the birth of Waterfall. So Waterfall in itself was introduced by this paper by Winston Royce in 1970, and actually it wasn't introduced as a process that should be used. And you can see the image above. This from the original paper. It basically presents a picture with the classic waterfall ladder. And the comment is pretty much explanatory: an implementation plan to manufacture larger software systems. And keyed only to these steps, however, is doomed to failure. So it was presenting waterfall as something that will lead you to failure, especially for large projects. But how comes that this was a paper introducing waterfall, and in the following decades, waterfall was the standard for everyone? Probably that's an hypothesis. There was some manager somewhere who looked at the paper and looked at the pictures. Maybe he was in a hurry for a meeting. The pictures had bad information design, if you will, because this comment explaining it's a failure, it's not near the picture. Near the picture, there's a nice, I can show you that. That's a nice implementation steps to develop a large computer program for delivery to a customer. So if you scroll the paper, just look at the pictures and the captions. It seems like a fine process, like especially if you don't know the craft and don't have experience. And that's what the caption, like the comment says. And maybe let's look at some other pictures from the paper. This is a paper. So the first picture is pretty much good. We analysis and then code. Okay, like that. Implementation for a small computer program. Okay, let's go. Oh, this is for a large computer program. Nice, understand that. Oh, this is okay. This starts to get complicated. And look at this. Oh, as I said. Oh, well, this, I don't know what this is. What should I do? Oh, that's worse. And yeah, maybe let's go back to I like that picture. So I think I propose this for the next project. So we can picture this manager or someone falling back to this, like everyone can understand this. It's accessible. Yeah. And I completely ripped off this like section from the original talk. But that makes sense because in the following decades, everyone was doing waterfall and was not solving, of course, the issues. And the paper has good contents and probably bad information designs and pictures. At least they don't convey too much unless you read in detail. So that's how Waterfall came along, and to this day, there are still people advocating for it or like compromising it with Agile, and you see like especially in courses and certification stuff, Waterfall being presented as an alternative. My take on that is that after decades of using this process, it was too hard to let it go and to completely deny it. So there's still some attachment. They're trying to repurpose the name in some way or like save it for some specific case just to avoid admitting it was not good, completely not good. Okay, there's one other point I wanted to make that's pretty much consequence of a waterfall approach, and that is that there is some people, if you remember the picture, that will be able to, with deep thoughts and nearly omniscience, design a system to the smallest detail with plans like an architect would do, building a bridge. Give me a second, sorry. Like design a building or a bridge or something like that. They would pretty much create blueprints for every small detail of the grand picture. And then you will have bricklayers and masons and stuff, and people like doing the groundwork, doing the actual constructions. But as long as they follow the plan, everything will be right, will be fine. And when there's a problem, it's probably because they're lazy or something wasn't done properly from the plans. And then you have the idea of testers, which I think of them as like government agents checking like your if you have a helmet or if you properly follow the instructions, and you'll have a bunch of red tape and things to follow. And as long as you do everything right, you write all the tickets with a title, subtitle, description, and whatever sections you want. Like just follow the plan in the detail, and you'll be fine. You don't need to think. So this, I think, is a bit of a consequence of that approach, and a sort of hierarchy of importance. Maybe I picked this pyramid, but probably testers are more important or more high level than developers, because the bricklayers are those who are checked. So my question would be, do we still have this mindset a little bit sometimes, also as developers? And this is like more or less presented in a way in which developers are the sort of the victims, or I'm trying to defend developers, but we can also flip that. And as developers, we can still have this mindset in which we have project managers or engineering managers, call it whatever you want, who need to create perfect tickets and perfect issues and perfect requirements, and will just we'll just try to implement whatever is written on the ticket. We won't go any further. We won't try to understand, and we're not responsible for bad requirements, or we don't try to fit the ticket in the big picture. Of course, I'm describing my let's call it temptation from time to time. I risk slipping into. And then we have a QA engineer. So how we think of that? We throw stuff to them. Whatever we did, oh, just check it. I won't lose time self-checking. I won't ensure it's properly done. I won't give you even instructions on how to check it. It's your responsibility. So I'm doing this exercise to understand that this is a mindset we can all have, and from different perspectives, it can be. It's not like necessarily one is one role is better than the other. It's a bad mindset that we can that can surface from time to time, even in our projects. So this section is, and that's those are the only two slides with colors. I managed to I added course because it was almost sad, but that's how it turned out. Yeah, I apologize. I hope it's like still entertaining. But let's create a parallel between physical and software engineering. This is another mind trap. I would think that's very well explained with a bunch of anecdotes and good examples in the original talk and the whole history of bridge building with failure successes. I'll cut it short. But basically, what we risk sometimes to think of ourselves as for physical engineering, you have the architects. They draw blueprints for the building, bridge, whatever. Then you have, as I said, bricklayers. They will build things, but they won't understand the whole architecture. They don't have the knowledge and insight of the architect, which is like a higher minded person. And then the bridge is actually built and gets used by people. You can work on it and so on and so forth. If we do a parallel in software engineering, maybe you will think as architects as like, well, maybe this was more for the 80s and 90s or early 2000s, but the architect will draw software diagrams. We still see software diagrams for complex AWS setups, but we also can think of these as tickets and issues in our ticketing system. Feature a big Jira board full of Gantt sequences and charts and projects and epics, and that's all planned out from the beginning to the end. We have the final date of the release, and everything will be. We have all the cycles laid out from today up to like 1 year from now. And then the developers come, they will execute piece by piece, and they're probably not as dumb as we thought in earlier decades. Like they're not mere executors, something more than that, but there's still a big high plan, and that's the execution. They are building the thing, and then finally the software is ready for use and can be deployed to production, so on and so forth. So the original talk by Glen Vanderburg does a great job and at shifting by Alessio, at shifting the perspective on this, because if we really think of what would be the plan for our software, I encourage you to like think about that for 5 seconds. What do you think it's actually the blueprint that gets executed? And big reveal, it's not the software diagrams, maybe partly also that, but for us, it's the blueprint is actually the code, and the code is the actual project that explains how this thing should be executed, and there's a different set of weights with physical engineering. Of course, for physical engineering, the project is relatively cheap, and actually building a skyscraper or a bridge is very expensive, and you can mess it up. You can't fix on the way. For us, it's different. For us, the actual builders are the compilers, the VM executing the code, and that's very cheap. That takes milliseconds or even less. So In our case, testing testing how good uh, the artifact is way easier, because it's like we will be able to build a bridge, then destroy it, then build it again with a small difference, then destroy it again, then build it with another shape, and then destroy it, and so on and so forth. And we can actually test the whole thing, not at scale, not like in scale like they would do for a bridge. You can build a small bridge with that shape and try work on it, a tiny bridge, and then you scale up when you actually build it. In our case, it's not that we don't have that cost, or not completely have that cost. It's not as high as would be for physical engineering. So this shift is, I think, a good thing to keep in mind when we work, because we don't risk dropping the ball on the big picture, on trying to understand the domain of the project to fit whatever we're doing the whole project, and maybe from time to time raise our hand and say, oh, as we all know, that's a staple in our company. Do we really need this? Can we do this differently? Can this be a more efficient solution? And be actually involved in the whole, and feel also that we can say things. Also, that's part of being consultants. So this wants to be a small reflection on ourselves, and try to identify points in which we let go of quote unquote true agile, or also we can call it agility. And we tend to fall back to something like the waterfall process, or similar stiff. I use the word stiff because it's more or less contrary to agile, and which tend to be more comfortable, because if you push the responsibility to others, you don't tend to think as much. If you um, don't try to understand the whole project, is easier. If you blindly follow practices or ceremonies, don't try to understand why they're there and what purpose they serve, it's certainly easier. You go on autopilot. But I think we should always be, I don't mean we need to question everything every second, but be on the fence and try to understand whenever we need to change something, whenever something stops making sense, or we need more structure or less structure as we go, because projects have different phases, and the team size can change, the stakeholders can change, and so on and so forth. So I wrote down a few issues I saw over time, like the idea of the certified Scrum Master. Nothing against certified people, but sometimes it can be an empty title, and if done like for the sake of doing it, it can be unhelpful. And of course, you can have a title, and if you don't actually grasp the core concepts, you're not doing that thing, even if you have the title. And I've seen this on a couple of projects. Also, rigid ceremonies. Maybe the team shrinks from 10 people to 2 people, and you pair a lot, and maybe you don't need a formal retro anymore. Maybe you don't need to take notes, and you can just have a one-on-one. I try to pick sort of more extreme examples, but it's all nuanced, as you can understand. And you can have different levels of these. maybe you can shift from live stand-ups to written stand-ups, or the opposite, because the teams needs it. And well, one other, like expecting perfectly specified requirements versus trying to understand the domain, trying to feel, trying to collaborate. And we need to actually get in the weeds of the project as much as possible, talk to people in the domain of the project. And the more we understand, the better we can do the work, the less we need to ask, the more context we have. And the final one I wrote is tool worshipping. And I think sometimes we end up, as I said, going on autopilot on some things we do, and we forget that those are just tools. Those are not ends in themselves. That can be a bit controversial, but I think testing is one of them. Testing is great. It must be there or not. If you're writing a one-off script, would you really need to test it to the bone? Or maybe you have an environment in which the cost of testing or completely testing is way high, and you have a deadline. Maybe you can push back testing for a while, or try to improve the environment first. I want to convey the concept that there's on everything there's a dichotomy, a balance, and between being too prescriptive and trying to be loose and to question a little bit our habits, and not mindlessly following whatever we did forever. So as I said, we need to find a sort of balance, tool in context. Remember that we need to be efficient, and efficiency, quality, and deadlines are all intertwined, and we can't have it all every time. And also, some things are like training wheels. I think someone told me, some agile nerd who knew a lot told me, oh, Scrum is a sort of training wheels for corporate, which are transitioning out of Waterfall. So it's kind of similar, but moving toward Agile. But the next step in many cases is something more free-form, like Kanban. And I'm not advocating that this should be a rigid evolution, like you go from Waterfall to Scrum to Kanban as you evolve toward more agility. This needs to be evaluated project by project, and I don't think I've seen two exactly equal Scrum processes or two Kanban processes which are exactly the same. It all needs to be adapted to the context. So this is an invitation for everyone, and for myself, before everyone else, to identify whenever we become a little more stiff, to always look for collaborating across roles, not create silos, like we have the architects or the project managers or whatever who needs to give us properly formatted stuff, or I want work. I'm surely guilty of that from time to time. And also look for ways to simplify the practices, or on the opposite, adapt, like more generally, adapt the practices to the situation. And well, of course, complicating stuff is always a cost. You should do that only when it's necessary. And yeah, one final call to action, and then I think we have some time to do some back and forth questions and discussions, hopefully sparked by this topic. I encourage again everyone to watch that Vanderburg's talk, to read the Agile Manifesto, to read Extreme Programming Explained, and those are like foundational and very short texts. And well, the first one, of course, is a talk, is a video, but they're very short and very down to the core, no fluff, and you grasp the concept, and especially, maybe more importantly, the why of every practice, because practices by themselves are empty. Like you just do the movements, that's not good. You should understand the why, and then maybe do that movement. So assess your project. Are your process too constrained or too loose? Is there a balance you need to regain? And yeah, what is that? Oh, reduce ceremony if possible. Like keep only the things that are actually useful. Always collaborate, streamline sprints, clean up backlogs, be very practical. Being pragmatic is always a good thing, but keep like good practices and quality. Like being practical is not an excuse to let go tests altogether. Of course, you shouldn't do that. But be mindful and understand the situation, and be like a real software engineer. If you want to know the meaning of that, watch the talk. But basically be empirical, not theoretical, adaptive, and down to the actual craft that we're all doing day by day. And we all hate bureaucracy, so keep that as few as possible. Thank you.